Hello everyone, it's me again, Heidi Tricia Santos, and for this video, we will be answering one of the problems in triple integrals, which is number 17 on page 15. Let's begin! So here's the problem. Use a triple integral to determine the volume of the region behind 6x plus 3y plus 3z equals 15, front of the triangle in the xz plane, with vertices in xz form 0, 0, 0, 4, and 2, 4. So before anything else, let's write down the notation first. Now, let's proceed with the sketch or analysis of the region that we are dealing with. So it says here that we need to get the volume of the region behind 6x plus 3y plus 3z equals 15. If we input this equation into GeoGebra, it looks like this. Here is the plane, and what we are trying to get is the volume of the region behind it. Going back to our problem, it was also mentioned here that the region must be in front of the triangle with the vertices in the xz plane. So by putting these coordinates in the xz plane, we will have this sketch. Since we already have the sketch of the region behind the plane and the region B, which is the xz plane, we can now list down the limits. For y, since we will be having our first integration with respect to y, because our region B is in the xz plane, we have y is greater than or equal to 0, but less than or equal to 5 minus z minus 2x. If you are wondering how we get 5 minus z minus 2x, you just need to solve for y in the equation 6x plus 3y plus 3z equals 15. Next, for x and z, we will be having two options for the set of inequalities. The first option is that the limits of x is greater than or equal to 0 but less than or equal to 2, and the limits of z is greater than or equal to 2x but less than or equal to 4. Meanwhile, the limits of the second option for x is greater than or equal to 0 but less than or equal to 1/2 z, and z is greater than or equal to 0 but less than or equal to 4 for z. Honestly, the order of integration does not really matter, since we will also arrive at the same answer given that the limits are correct. With that, let's just go with our second set of inequalities, since this option could make our integration easier because the lower limit is only 0. Now, let's set up our integral with these limits. Well, integrating a triple integral is also similar to integrating a double integral. We have to integrate the innermost part first. So, the integral of dy is just y. And evaluating this from 0 to 5 minus z minus 2x, we get 5 minus z minus 2x minus 0, or simply 5 minus z minus 2x. Next, we will need to integrate this with respect to x. So the integral of 5 is 5x, the integral of negative z is negative xz, and the integral of negative 2x is negative 2x squared all over 2, or simply negative x squared. Again, let's evaluate this from 0 to 1/2 z. So let's replace all x with 1/2 z, and after the minus sign, replace all x with 0. However, since evaluating the lower limit will just give us 0, we will just focus on evaluating or simplifying the upper limit. So now we are left with a normal single integral. Let's finish this by integrating with respect to z. The integral of 5 over 2z is 5z squared over 4. The integral of negative z squared over 2 is negative z cubed over 6. And the integral of negative z squared over 4 is negative z cubed over 12. So we are now close to getting the final answer. We just need to evaluate this from 0 to 4. So let's replace all j with 4. After the minus sign, replace all j with 0. But then again, since evaluating this will give us only 0, let's just focus on simplifying this part. So here is the process. And that's it. The volume of the region behind the given plane and in front of the triangle's vertices is 4. So that's all for this video. Have a nice day ahead.